Good morning, everyone. My name is Rohit Balakrishna, and today we are going to discuss a seminar topic called as GPU-based real-time traffic sign detection and recognition system under the guidance of Dr. Arun Tigris. So let's have a quick introduction about it. Traffic signs are nothing but it's the important infrastructure along with of the road, along with the dividers, traffic signs and lanes. Along with those, we have something called as traffic signboards, which are put up along the road lines. So what does this traffic sign do, or how does they help us? They typically depict some or the another information to the driver, alert messages like speed limits, sharp curves, dangerous zones like hospitals, schools, and speed breakers, etc. So to depict those information, we use traffic signs along the road lines. So how does this information is encoded onto the signboards? Basically, we have the signboards which are like which depict using some colors like red, green, red for stop, green for go, and some shapes like a circle with a cross mark on it. There is no parking over there, and somewhere we use some pictures also like work in progress and all. So these were some examples for the road traffic signboards. So what if the driver fails to notice these signboards? Naturally, he will be ending up with some rash situations like accidents and road accidents and all. So due to this, there will be deaths occurring all over the world. So how can we manage this, or how can we control this? How can we do it in an automatic manner, like without even if the driver fails to notice it, we should be in such a situation that it can be automatically detected, and thus making the driver's life easier even if he is not noticing, and can minimize the accident situations. So let's move into some paper discussions. So after having a literature survey of around 8 to 10 papers, I can conclude that these 4 papers would build up a basic platform for today's discussion. The first being a GPU-based real-time traffic sign detection and recognition system. Here in this paper, it talks much about a real-time based application where the detection rate, where it can detect a 48 class of signs which are preloaded into the intelligence of the system, and the detection rate is about 91.69% and recognition is about 93.77%. There is some difference between recognition and detection, which we'll be talking in the further slides. So the second paper, known as vision-based traffic detection and recognition system using current trends and challenges. This was released recently in 2019. Here they have classified the traffic detection into simpler 3 steps, like they are detection, tracking, and classification. So on these 3 detection or these 3 steps, the entire classification is done. The more about this will be, we have a further separate slide. There will be talking about much about this. And the next slide, next paper goes like this: a real-time traffic sign recognition in 3 stages. In this, apart from talking about much more about the stages, the color enhancement topic is much more enhanced, like the need of enhancement, color enhancement, and much other image processing techniques. And lastly, an automatic sign detection and recognition system based on color segmentation, shape matching, and SVM. So the main goal of this paper was to talk about TSDR, which stands for Traffic Sign Detection and Recognition System, which was conducted by the government of Malaysia using was carried out around the whole day from 8 a.m. to 8 p.m. They collected all the different types of images in different lightning conditions, different climatic conditions, and so on. So let's go for the next slide. So what is the basic problem? Why are we not visible, says the traffic signs? There are basically because of 2 reasons that traffic signboards are not visible. One is temporal and another being permanent. Temporal, we can say that if there is some illusion of light, some sunshine is falling on the traffic signboard, or there is some dirt on it, or some other reason. And the another reasons being a permanent, like if it is affected by the bad like climatic conditions, they are rusted, or they are permanently occluded, or they are purposely vandalism, like purposely spoiling up of the signboards, like we can see in the image number 3, C. And last being multiple signboards appear at the same time on the same lane of the road. So even this can cause a problem. So let's discuss about different types of signboards available. There are very vast classification of signboards. Like there are different types of signboards for stop, parking, and some are like informational signboards for the kilometer average and all. So since there are many different types of signboards, again all the different countries have the different types of signboards in their own country for these signs. So this would make up a huge database if we are developing a system. Hence, to overcome this situation or this problem, there was an international treaty signed in the year 1968, which is commonly known as the Vienna Convention Road Signals and Signs. Under this treaty, it was discussed that it was broadly signboards were classified into 8 categories. Like we can see here all the images. The first one being a danger warning sign, then comes the priority sign, prohibitory sign, mandatory sign, a special regulation sign, information sign, detection sign, and an additional panel. So these were the 8 categories where all the signboards were broadly classified. So keeping this information in our mind, let's speak something about TSDR. So what is TSDR? TSDR is nothing but automatic traffic sign detection and recognition system, where we can automatically detect the signboards while we are traveling from the roads. Even if the driver fails to notice them, the system should be able to capture these signboards without the human interference. So how this works is, it basically works on capturing the visual photos. Like it collects the raw data and captures those raw data and sends it to the machine's intelligence. So basically how it works is, it is categorized into 3 categories, like discussed in one of the papers. It works as detection, tracking, and classification. Detection tries to detect the signboards, and while the tracking keeps on monitoring for upcoming new signboards on its way. While lastly the classification will classify these detected signboards into the 8 categories as discussed earlier. So let's move on to the next slide. So let's talk about color enhancement. So why this is required, or why we want in our paper? So basically the color enhancement is required to detect the region of interest. So what is region of interest? As we capture the image, as it is acquired or acquisitioned by the cameras, it so happens that not only the signboard is captured, also some background noise, some unwanted images are also being captured. So we don't want those images, we want our region of interest. To highlight that, we perform this color extraction. So how we are going to perform this? Firstly, we are going to use the adaptive threshold method. Using this, the red enhancement is done, red color enhancement, by using this mathematical expression which says that fr is equal to maximum of 0, minimum of xg, that is the pixel value of red and green and red and blue, divided by s. S is nothing but summation of all these pixel values. Then later we move on to something called as global thresholding. So there what we do, now we convert this color enhanced, that is red color enhanced element, into a binary element that is represented by IR. So using this binary image, we can carry out image processing techniques in a controller. Similarly, the blue enhancement is also followed by the same steps, and we get the IB, that is nothing but the binary image, and we perform the other image processing to have a clear image. Now we can see that we have a better image quality in the other section at the right side after color enhancement. And before color enhancement, the image was too dark and we could not distinguish properly between the region of interest and the noise. So let us go for the next slide. All the slides are visible, sir. I request all the panel. Yes. let's speak something about traffic detection, traffic sign recognition. So how are we going to achieve this goal? The main goal of the discussion is to achieve this. So we are first going to convert the RGB colors, whatever the RGB colors are there, we are going to convert them into a grayscale image using two techniques. Using the technique of histograms oriented gradients. So this will extract the image, will distinguish the color extractions and give us a much more developed, much more enhanced image. Then using this information, we are providing this information to SVM. SVM stands for support vector machine. So how we are going to do this? In after not only doing this, there are also chances of occurring the false detection. Like it so happens that the image the signboard is already detected, but it goes on detecting it again and again, making it a false data. So to avoid this, the red and blue announcements are made only on the frames that are detected positively by the grayscale imaging. If he detects it positively, then only the other further steps are being followed. Once this is done, then we need to classify them as discussed into 8 categories. We need to classify them. So this work will be done by the support vector machine. It is a high class algorithm which naturally divides them into 8 categories and makes them work much easier. So looking into the methodology is again divided into modes, broadly divided into 2 modes, namely the training mode and the testing mode. In the training mode, we pre-program the memory of the training database. Like we try to collect some images from the images in the raw data form. Then we fill it to the data intelligence and then try to wait for its validation. On the other hand, in the testing case, we do not pre-program or do not feed any image to the its memory, but we directly expose it or throw the new traffic signs which it has never been seen before. So in this manner, the training and testing mode work. And as discussed earlier, the binary images which were generated are again fed into the color segmentation for better image quality, and then we pass it on to the feature extraction. The feature extraction is again it has 2 major works to be done. The first is to again filter out the noise and other redundant components of the image, and secondly it has to ensure that minimum space is required or it occupies minimum space for keeping these raw data images, storing them, and for other performing concepts. Right on, so let's go some experimental details. So it was found that the entire work was carried out on a GPU. The GPU stands for Graphic Process Unit, which was namely a Tesla K20 platform. So here it takes around 13 to 17 milliseconds to boot up, and later the detection and recognition patterns as compared to CPU and GPU were much more like there was a large gap between them. So we can see a graph over here on the right side. The red line represents the CPU graph, while the blue line represents the GPU graph. So the time taken for the execution and giving us the results for CPU is much more as compared, or we can say it is negligible as compared to GPU, because the GPU itself works on around a capacity of 2000 images, and it performs the Hawk and SVM techniques also. So let's have a much more detailed explanation about it. By using GPU, the problem was not totally solved. The old traditional like open series library functions were used, and it produced a large peak. Like we can see on the left side the graph showing very large or pointed peaks. But after performing some optimized code, we were able to see suppressed curves on the right side. So this was a major we can say that major advantage and changes seen after using optimized code. So what was the advantage of this optimized code? It made the system very fast, as the system we are working on it is very crucial and is time considered. So we need to be as quick as possible and accurate as possible. So by doing this, we were able to achieve a faster rate of 31%, and we were able to achieve there was a difference of GPU with the traditional method of 21.3 frames per second, and that of optimized code was 27.9 frames per second. So we were able to achieve much more frames at the higher rate. So finally, concluding today's topic, so we can conclude that all this system is pre-available, but it has some advantages or limitations. That is, the detection rate is not to the 100% but 91%, and whereas the recognition rate is about 93%. No doubt, all the recognition of any, irrespective of the sizes, frame size, the system is able to detect them and locate which type of signboard it is. And also it is able to detect in adverse conditions also, even if the signboard is partially occluded. As we saw, it was not visible. Even in those situations, the system is able to somewhat capture those signboards also. So further extending or sowing the seeds for the further scope, we can conclude that we can achieve much more accurate system with a higher rate of detection, with much more reliable system than we have at the present situations. So I would like to conclude